So PCR is polymerase chain reaction, and this test is to amplify one segment of target DNA that you want to copy to make into millions of copies of this one segment. So you start off with your sample of chromosomal DNA, which you call your target DNA, and then you have the other components of this test are your Taq polymerase, your free nucleotides, and your DNA primers. Your Taq polymerase is what is going to be able to bind the DNA primers and the free nucleotides to the target DNA, and your DNA primers form your hydrogen bonds and your base pairing with the target DNA, and your free nucleotides create the binds between the base pairs. So your adenine with thymine and cytosine with guanine. So to start off, you have to raise the temperature to 95 degrees Celsius, and that will denature the DNA. And the temperature is then, and it'll break the hydrogen bonds. So once the hydrogen bonds are broken, the temperature will be lowered to 60 degrees Celsius, and that is to let the primers attach and recreate the hydrogen bonds between the two DNA strands. And once that happens, the temperature is raised back up to 72 degrees Celsius, and that's the optimal temperature for Taq polymerase to perform. And that will, once the temperature is raised, the Taq polymerase will begin its polymerization by adding the free nucleotides to the DNA primers until the free nucleotides have base paired up all the way on both DNA strands. And once the free nucleotides have paired up on both strands of the target DNA, you have one complete copy of your target DNA, and this will continue for 25 to 30 cycles, and take several hours. And by the end of your 25th cycle, you should have almost 33 million copies of your target DNA that you started with.